In this lesson, you will factor binomials that are difference of squares and use the difference of squares to solve equations. Now, we did this earlier in the chapter. Remember that if I have a squared minus b squared, that's always going to be factored as the square root plus the square root, and then the square root minus the square root. This is what we call difference of squares, remember, early in the chapter? So anything that is in this form can be factored this way. So this is a perfect square and this is a perfect square. So we will factor in this pattern. Square root, that'd be 4h, plus square root, that would be 3a, and then we do the difference. Square root minus square root. So this is the factored form of 16h squared minus 9h squared. So this should go a lot faster. It should be a lot easier. You're just following that pattern all the time. Perfect square, perfect square. So it would be square root minus square root plus square root. It doesn't matter which way you go. You can go minus first, plus first, minus first. Now if you look at this last example, these are not perfect squares. So we cannot factor them in the pattern. But we can look for a common factor. I can divide those both by 3. So I divide by 3 and I get 3 out front, and then I have 9. Excuse me, we can divide by 3g. I apologize. 3g, that has g cubed, that has a g. So 3g out front, and then this would be 9g squared minus 3. Because 27 divided by 3 is 9, g cubed divided by g is g squared, 3 divided by 3 is, excuse me, that should be a 1, and g divided by g is 1. So this is our factored form. Now if you'll look, this is a perfect square, and so is this. So now we've factored out of 3g, but now we can use the pattern. So square root minus square root plus square root. So this is the factored form of this particular binomial. So look for a common factor first if they're not already perfect squares. Try the examples in your notes. Now we might be able to try a technique more than once. If you'll look, this is a perfect square and so is this. So we're going to do square root plus square root minus square root. Now if you would look, this is a difference of squares. This cannot be factored because it is a sum of perfect squares. We can't factor that using the pattern, but we can factor this using the pattern. Square root minus square root plus square root. So this is the complete factored form. Anytime you have a difference of squares, you can factor using that pattern. Same thing goes here. This is a perfect square, so is this. So I have 25 plus x squared, and I have 25 minus x squared. Those were the square roots. This cannot be factored any further. We are done. But this is a difference of squares, so I have the perfect square plus and the perfect square minus. So now we are completely factored. You try the examples of factoring more than one time in your notes. Now if you will look, we have a common factor to start. So I can divide both of these by 5, and I can divide both of these by x. So when I divide by 5x, I get a 1, and that'd be x to the 4th. Divide this by 5x, and I get minus a 9, and the x's cancel. If you'll look, these are a difference of square. So I have 5x times x squared plus 3 times x squared minus 3. Now if you'll look here, this is a perfect square, but this is not. This is a perfect square, but this is not. So this is as far as you can go. I factored the 5 out first, and then I have a difference of square here. Remember, you can only use the pattern if they're both perfect squares. This is, but this is not. Now, this is asking me to factor this set of terms, and what I would do is factor it like you would factor by grouping. Find something that these first two have in common. And I would say you could factor out, of these two, maybe a 7x squared. So if I take this divided by 7x squared, that leaves me just 1x. This divided by 7x squared would leave me a plus 3. Those x squareds would cancel. Now remember, when we factored by grouping, we want to leave a plus 3 here. So let's divide by a negative 7. And when I divide by a negative 7, that's going to allow me to have this positive x like I want, and a negative divided by a negative is a positive. Now do you see what we can factor out of here? X plus 3. So I'm going to put that x plus 3 out front, and I'm going to factor that x plus 3 out of each of these terms. And what's left behind is 7x squared minus 7. Now we can keep going. Do you see the common factor here that we can get out? So I'm going to leave this x plus 3 out front, but then I'm also going to take out a 7, and I'm going to put that 7 out in front of it all. This becomes x squared minus 1. So do you think we're done now? This is a perfect square, and this is a perfect square, so we can use difference of squares. So it's 7, x plus 3, x plus 1, x minus 1. Now are we done? You bet. No perfect squares left. Everything is completely factored. So we know for sure that we are done. If you would like to look at the work again, rewind it and watch it again, please do so. We know anytime we have a power of 3, we have to have 3 binomials. 1, 2, 3, we know we're right. That's another way you can check yourself. All right, try an example of more than one step in your notes.